Welcome you all to Sequence and Series third and final part. In the first part, we had seen how to find out the general term, and then using that we can find out the sum also. In the second part, we have seen progressions and we have covered some key questions from the last 5 years of CAT. In this part, we will see all that is remaining as part of Sequence series, the miscellaneous series, AGP series, through some of the questions that have been part of CAT in the last 4 to 5 years. I hope that sounds interesting. So let's begin. Xn plus 1 is equal to xn plus n minus 1. Again, it's a pattern spotting problem. So let's see. We can say that x2 is equal to x1, which is minus 1, plus n minus 1, which is 1 minus 1, so 0, right? So x2 becomes minus 1. Now x3 will become x2, which is minus 1, plus here I will have 1, so that is 1, so this becomes 0, right? Next x4 will become x3, which is 0, plus here I have 4, so here I'll have 2. Note the pattern. Here I have n plus 1, here I'll have n minus 1, so difference of 2, so this becomes 2. So x100 will be what? Starting with minus 1, what is the pattern building up to be? See, you have to realize that x2 will have 0 here, right? x3 will have 1 here, so on and so forth. So x100 will bring a 98 here. So minus 1, and then I have 1 to 98. What is this? 99 into, so number of terms is 99. So 98 into 99 divided by 2. So 49 into 99. So 49 into 99 minus 1. So what is 49 into 99? If you just multiply it and you add, minus 1 to it, 4850 is the answer. I hope this is clear to you. From the last digit also you could have figured out that only C or D could be the answer. But the product was not nearing 4950, hence we marked C. I have x1 minus x2 plus x3. Again looks like a pattern spotting problem. So now if I take x1, that becomes 1 plus 2, so that is 3. x1 minus x2, so 2 into, so this is n into n plus 2, right? So 2 into 4, that becomes 8. So quite clearly x2 must be equal to minus 5. Now if I take 3, x1 minus x2 plus x3 will become 3 into 5, that is 15. I know x1 minus x2 is equal to 8, so x3 is equal to 7. Now if I take 4, x1 minus x2 plus x3 minus x4 is equal to 4 into 6, 24. So this is 15, we know this. So x4 is equal to minus 9. So what's the pattern now? I have to find out 49 plus 50. If you've seen the pattern, x1 plus x2 is equal to minus 2, 3 plus minus 5. x3 plus x4 is equal to 7 plus minus 9. So the pattern is quite clear. The answer is minus 2. I have x0 is equal to 1. So x0 is given as 1, x1 is given as 2. What will be x2? Just put it here. So if I have x2 here, I'll have 1 plus x1, which is 2, divided by x0, which is 1. So this is 3. What is x3? Now what is x3? 1 plus 3 upon x2. So this is 2. x4 will be 1 plus 2 divided by 3. So what is this? This number is again 1, right? This number is again 1. Now what will be x5? Similarly, if you will calculate, so 1 plus, this is 1 divided by 2. So this becomes again 1. It is, going in a loop, right? So 1, 2, 3, 2, 1. Again going in that loop, 1, 2, 3, 2, 1. So 5 terms will keep on going, right? But it has started from 0. If it had started from 1, then x to the power 2020 will be the multiple of 5. But since it has started from 0, right? So therefore x 2021 will not come at 1, but it will come at 2. I hope this is clear to you. So answer is answer option D. A similar pattern spotting from CAT 19, A1 minus A2 plus A3 minus A4 going on and on. So now I can say that A1, if I take n is equal to 1, so that becomes 1. So A1 minus A2 is equal to 2. A2 will be minus 1, right? So A1 minus A2 becomes 2. So 2 plus A3 is equal to 3. So A3 becomes 1. 3, A1 plus A2 plus A3 minus A4 is equal to 4. So A4 is equal to minus 1. So you can see that there is this pattern repeating. A1 is equal to 1, A2 is equal to minus 1. So if I add the two terms, if I add consecutive terms, odd and even term, that becomes 0, right? It finally will leave me one odd term, which is 1023, and we know that the odd term here is 1. Hence the answer to this question is answer option B. Moving forward, number of common terms in two sequences. The way to find out is very simple. Find out the first common term. First common term is 19. Then, and what's the common difference here? You see the common difference here is 4, 4. Here the common difference is 5, 5. So LCM of the common difference is 4, 5 into some variable k. That's the general form of the sequence which captures the common terms. So that becomes 19 plus 20 into k. Where, till where can I go with the value k? I have 415 here. So quite clearly, if I put k is equal to 19, this becomes 380 and this becomes 19, becomes 399. If I go k is equal to 20 here, then I will exceed 450. So k is equal to 20 is not possible. So k starts from 0 when the value is 19 and goes on till 19. So 20 values are possible. Finally, the AGP series. I hope you've solved some AGP series also this season. Let's see. So S is equal to 1 into 2 plus 2 into 2 square plus 3 into 2 cube, 100 into 2 to the power 100. Why is it called arithmetic or geometric progression? Because you can see the first part is in AP 1, 2, 3, 4. Second part is in GP 2, 2 square, 2 cube, so on and so forth. Now what do we have to do? The common ratio of the GP is 2. So just multiply the series by 2 and write the terms with a gap of 1. So multiply it, write it 1 into 2 square here. Multiply it with 2, write it here, 2 into 2 cube. Right? Now if I just take a difference here, so that becomes minus S is equal to 1 into 2, 1 into 2 square, 1 into 2 cube, going on 1 into 2 to the power 100, and I have minus 100 into 2 to the power 101. What is S? S is 100 into 2 to the power 101 minus you have this entire GP series. So that becomes 2 to the power 100 minus 1 divided by 2 minus 1. So that becomes 1. So that's the answer for your question. I hope this is clear to you. I hope you enjoyed all the questions. With that, we come to the end of series. Thank you so much. Revise all the 3 parts. God bless you all.